LIGO, the straightest thing in the universe, according to some. I'm not going to discuss the claimed purpose of this facility, but rather talk about the practical mechanics and geometry of the structure itself. First, we need to establish a few irrefutable truths. A straight line does not bend, and a curved line is not straight. Pretty sure we can all agree to that. Two straight lines cannot enclose a space. Points are that which has no dimension. It's merely a location in space. Lines are defined as length only and is the distance between at least 2 points. Planes are two-dimensional and defined as length times breadth and require at least 3 coplanar points. Three-dimensional shapes are defined as length times breadth times depth and require at least 4 points and at least 3 planes. A circle is defined as a plane bound by a curved line called its circumference. The radius is a straight line that extends from the center of the circle, equidistant to every point along its circumference. A perpendicular is defined as when a straight line is set upon another straight line, the adjacent angles are equal to each other and each line is perpendicular to the line on which it stands. Horizontal is perpendicular to vertical, and vertical is perpendicular to horizontal. Horizontal and vertical are orientations of planes where horizontal is parallel to the plane of the horizon, and vertical is up and down, perpendicular to the horizontal. A horizontal line between 2 points is a straight line, and a vertical line between 2 points is a straight line. If a vertical is perpendicular to horizontal, and a horizontal is a straight line, then vertical is perpendicular to every point along a horizontal straight line. If a plumb bob is perpendicular, meaning a tool that hangs down, establishing a vertical plane of reference, and is perpendicular to the plane of the horizon, then everywhere a plumb bob is hung, it will be perpendicular to horizontal. This means verticals are parallel. Some people will claim that verticals are not parallel. This claim necessarily requires horizontal to bend, which it cannot, if we use horizontal as a plane of reference from which to measure change in elevation, or in other words, to survey. LIGO, which is said to be the straightest thing in the universe, is a structure consisting of 2 arms forming a right angle, with tubes housing high-precision lasers that are fired and bounced off of mirrors that are hanging 4 kilometers away in perpendicular directions. The mirrors are hung as pendulum, isolating them from vibrations of the structure or anything that might influence their ability to reflect the beam, which must be perpendicular to the mirrors in order to bounce a laser back and forth over a distance of 2.5 miles in both directions, some 100 times per millisecond. That's 100 returns in 1/1000th of a second. Here's a claim from an article I found. Each facility, quote, each facility includes an L-shaped vacuum chamber with legs 2.5 miles, that's 4 kilometers long, containing an interferometer. The detector's lasers can discern movement between their mirrors with a mind-boggling accuracy of 1/10,000th of the width of a proton. I have only one question. If the lasers must be that accurate over that distance, how can a pendulum mirror not hang perpendicular to the horizontal plane the arms are situated on? Let me demonstrate. A tangent is a straight line touching a circle, but not intersecting the circumference. If one of the arms is tangential to a curved surface, where plumb is a vector to the center of that circle, each end of the arm will have a pendulum mirror leaning away from each other and not perpendicular to the laser beam. If one of the arms is increasing or decreasing in elevation from one end to the other, the same principle applies, as the tangent is just closer to one end with a greater angle of deflection for the beam hitting the pendulum mirrors.